Greetings, math students. It's Mrs. Marcellus in Gottlieb. Today we're going to take a look at equivalent expressions. We will be simplifying algebraic expressions and also factoring them. Our learning objective is students will simplify algebraic expressions with one and two variables by applying the commutative, associative, identity, and distributive properties. We have a few vocabulary words today, Gottlieb. The first one is term. A term is a part of an algebraic expression. The terms of an algebraic expression are separated by addition or subtraction signs. Like terms. Like terms contain the same variable raised to the same power. And to simplify expressions, we will be combining like terms. Coefficient. Ooh, that's a fun word, isn't it? Coefficient is the numerical part of a term containing a variable. For example, if we have the term 10x, the coefficient is 10. And finally, we have constant. A constant is a term without a variable. For example, 5 would be a constant. Let's take a look at an example. If we have the algebraic expression 5x plus 8 minus x, we can see that we have three terms. Each term is separated by the addition or subtraction sign. The like terms have the same variable raised to the same power. Therefore, 5x and x are like terms. The coefficients are the numbers that are multiplied times the variable. Our coefficients are 5 from the term 5x and 1 from the term x. If you remember, whenever we have a variable by itself, it is the same thing as 1 times that variable, even though the 1 is typically not written. And finally, our constant in the expression is 8. In our lesson, we are going to use this information plus all of the properties we have learned so far to simplify expressions and factor expressions. Are you ready to try some, Gottlieb? The first thing we're going to do is simplify expressions. To simplify expressions, we combine like terms. In our expression 2x plus 5x plus 3x, we have three terms, and they are all like terms because they all contain the same variable of x. If we look at this pictorially, this means we have 2 times x, or 2x, plus we have 5 times x, and we have 3 times x. We have 2 plus 5 plus 3, all times some unknown value of x. Therefore, to simplify the expression, we add the coefficients of the like terms. 2 plus 5 plus 3 equals 10. To simplify this expression, we will simply write 10x. Let's try another example. In this expression, we will simplify 4x plus 12 plus x. 4x and x are like terms because they contain the same variable raised to the same power, but 12 is a constant, so it is on its own. We can combine 4x plus x by adding their coefficients. Since x is by itself, we know that the coefficient is 1. 4x plus 1x equals 5x, and we also have our constant of plus 12. Let's simplify the expression 2 times 6x. If we were to write this out, this would mean 2 times 6 times x. However, unless we know what x is, we cannot do anything with the 6 times x. We can use the associative property, though, to move the parentheses over and make this 2 times 6 in parentheses times x. And it becomes 12 times x, or 12x. We don't need to write out all of these steps. We can simply look at this expression and know that we need to multiply 2 times 6 to give us 12x. Let's simplify 2y plus 6x plus 10 plus y. In this expression we have two different variables and we need to look for the like terms. This means we have 2y, we have 6x, we have a constant of 10, and we have 1y. The like terms in this expression are 2y and y. We can combine those two terms. When we write our final expression, usually I like to go alphabetically, and I would write 6x plus 3y, which is the 2y plus the 1y, plus 10. However, because addition is commutative, if you had written 3y plus 6x plus 10, it would mean the same thing, and that would also be an acceptable answer. To simplify this expression, we will use the distributive property. First, we will multiply 4 times 5x, and that will give us 20x. Then we will multiply 4 times 3y, and that gives us 12y. Since 20x and 12y are not like terms, there's nothing more we can do to simplify this expression. Next, we'll take a look at factoring some algebraic expressions that contain more than one variable. When we factor an expression, we are essentially undoing the distributive property. To factor the expression, we'll set up our division bracket. We will divide both of the terms by 5. 15x divided by 5 will leave us with 3x. 40y divided by 5 will leave us with 8y. And we'll keep the addition symbol in there. Our final answer is 5 times the quantity 3x plus 8y. We can always check our answer by applying the distributive property. 5 times 3x does equal 15x, and 5 times 8y equals 40y. Let's try another example. The greatest common factor of both 12 and 20 is 4. So we will divide out the 4, and that leaves us with 3x plus 5y. Our final answer will be written in the form 4 times the quantity 3x plus 5y. Before moving on, let's take a look at what happens if you don't remove the GCF. We'll set up our division bracket, and let's divide both of these by 2. 12x divided by 2 will give us 6x, plus we will have 10y. However, we're not finished yet. Both 6 and 10 can still be divided by 2, and that will give us 3x plus 5y. Now the only value that both 3x and 5y can be divided by is 1. In order to find the GCF, we will need to multiply the factors we removed. 2 times 2 is 4. That gives us 4 times 3x plus 5y. As you can see, we get the same result. Gottlieb and 5 of his friends decide to watch the mountain climbing contest. Admission to the contest is X dollars per attendee. 3 of Gottlieb's friends also purchase a snack box that costs $7. Write and simplify an expression that can be used to calculate how much they spent in all. One way to write it is to consider first the cost of admission, then the purchase of the snack boxes. We have Gottlieb and 5 of his friends, so we know that 6 goats attended the event. First, we can represent the cost of admission by multiplying 6 times x, which is the cost per ticket. Then we will add the cost of the snack boxes that 3 of Gottlieb's friends purchased. That would be 3 times $7 per snack box. To simplify the expression, we would end up with 6 times the cost of admission plus $21. In this problem, we have 6 groups of goats. In each group, there are 2 females that weigh F pounds each and 3 males that weigh M pounds each. Write and simplify an expression that can be used to calculate the total weight of the 6 groups of goats. One thing we could do is figure out how to represent the weight of one group of goats. Then we can multiply that times 6. To represent the weight of one group, we will need to add together the weight of the females and the weight of the males. There are 2 females that each weigh F pounds, so we would represent that with 2 times F. Then there are 3 males that weigh M pounds each, so we would add plus 3 times M. This gives us the weight of one group of goats. We would have to multiply this whole quantity times 6 to get the total weight of 6 groups. Then we can use our distributive property to simplify. We would multiply 6 times 2F, and that gives us 12F. Then we will multiply 6 times 3M, and that gives us 18M. The total weight of the 6 groups of goats can be represented by the expression 12F plus 18M. Gottlieb is Y years old. His sister is 6 years younger. Their mother is 3 times as old as his sister. Their father is Y years older than their mother. Write and simplify an expression to represent their father's age. Gottlieb is Y years old. His sister is 6 years younger. This means that the sister is Gottlieb's age of Y and then minus 6 because she is younger than Gottlieb. Then the mother is 3 times as old as the sister. So we would represent that with the quantity Y minus 6 times 3. Finally, the father is Y years older than their mother. Therefore, we will have the mother's age plus Y years. Now that we have our expression, we can simplify it. We'll multiply 3 times Y and get 3Y. Then we'll multiply 3 times 6 to get 18. Since there is a subtraction symbol inside the parentheses, we'll have 3y minus 18 plus y. Next, we need to combine our like terms. 3y plus 1 more y gives us 4y minus 18. The father's age can be represented by 4y minus 18. Well, Gottlieb, you sure have a nice family. I really enjoyed getting to meet them when I was out visiting you in Colorado, and I bet you're probably anxious to get back to see them, aren't you? It has really been great working with you as we've learned these foundations of algebra, and hopefully we'll get to work together again someday. Well, math students, this is Mrs. Marcellus and Gottlieb signing off for now.